components of a pump, centrifugal pump? Anybody, guys?
Foot valve,
Yeah.
strainer, impeller, and then casing, and then discharge valve, IF and MP.
Okay. You have didn't mention a few things, I think, like the gland packing or mechanical
Can I
seal,
tell?
the shaft, the motor, the. Yes, please answer.
Can
Gaurav. You are not audible, Gaurav.
I am starting from the strainer. Strainer. Then,
Yeah.
hello.
Yeah. Now I'm hearing you. Yeah.
At first, I am starting from strainer, then foot valve, then suction line, impeller, casing, priming port, air vent cock, discharge valve, and shaft, motor, mm, gland packing or mechanical seal, or wear ring, lantern ring. That is.
Okay. What is a wiring? And where is this wiring fitted? Can you answer, Gaurav?
Yes, wiring is a softer material than the parent material, which resists wear and tear between the parent materials like shaft or the casing and the shaft and the impeller, and it will be fitted between the impeller and the shaft, or another wire can be it will be fitted between shaft or impeller. That is. It will resist the wear to it will prevent the wear of the parent material. At first, it will be wear, and then it will allow to wear the parent material.
It's made up
I
of
think that is.
a more softer material, right?
Yes, softer material than the parent material.
Than the parent material, yeah. Okay. Does anybody have to add something in this answer? Akhil? Akhil, are you there? Yeah.
Yeah,
Do you want to add anything else in this answer?
yeah, it doesn't allow the flow of water from the high pressure discharge side to the low pressure suction side, back to the suction side.
Where is this uh, ring fitted?
Yeah,
Where is this ring
it's
fitted?
fitted between the shaft and the casing.
Shaft and the casing, or it can be fitted in the impeller and the shaft too, right?
Yeah,
So I have one doubt here. I've read somewhere
Which
that
ring? Which ring?
both
Where ring?
welding. Yes.
Where ring? So it is fitted
I've
between
read
the casing of the pump and the impeller. It is not between
casing
the
of the
shaft and
pump,
the impeller. Yeah. Casing of the pump and the impeller.
casing of the pump and the impeller.
Yeah.
So it's
So at the
it's
suction side of the suction side of the impeller and the casing prevents the wear.
suction side of the impeller and the casing.
Yes,
So we can say like it's fitted in between the shaft and the casing, right? So the correct answer will be it's fitted
that is
between the.
stuffing box. That is stuffing box.
Okay.
What you are speaking is stuffing box. This is different.
Yes. Yes. Correct. Okay. So where is the O-ring fitted in a centrifugal pump? Can anybody answer where is the O-ring fitted? Kamlesh?
No, actually, I couldn't find the answer about the
Me
O-ring.
too, bro. I
But
was right before this session. I was trying to find the answer, but I couldn't find where is the
yeah,
O-ring fitted.
I couldn't find anything that is satisfactory enough to me, so I don't have anything to present here.
I think it is in the mechanical seal. I think it's somewhere in the mechanical seal.
Sorry?
That is wrong.
It's somewhere in the mechanical seal only. This O-ring is fitted
It's in
commonly in
mechanical
the
seal.
mechanical. Yes.
Okay, but I think we have
Its
to
main
find
function is
this
to
answer.
prevent leakage. Prevent leakage, I guess.
Yeah, bro, is right.
Okay, it's fitted
Uh,
in mechanical seal.
Yeah, and also in shaft sleeve. Only in these two places you can find O-ring.
Okay,
O-ring
it's
means
fitted.
the black ring thing we use generally for sealing purpose, right?
Yeah, it can be other material also, not just black.
I mean, in general purpose, we see that black Teflon thing.
Yeah, yeah.
So can you please tell us more about it, where it's located, and main purpose for it?
Bro, it is only located in your mechanical seal. That's all, and also
Okay,
in your shaft sleeve.
Okay,
mechanical seal
With
and shaft sleeve.
shaft sleeve,
Yeah, yeah. In shaft sleeve,
with
it will be.
shaft sleeve
Yeah,
of the same stuffing box only.
pump shaft will have a sleeve which will also rotate
Okay,
along with the shaft. So inside that there will be a O-ring to prevent the leakage.
okay.
Okay, so in case of mechanical seals, instead of using that stuffing material, we are gland packings, we are using O-rings.
No, no, no.
Somewhat.
No, mechanical seal have many parts, not just O-ring. It will come with a spring and a O-ring.
Okay,
And yeah, there are two parts. One is rotating part, other is stationary part.
okay.
Yeah, for that, you need to understand the working of mechanical seal.
Yeah, so I'll go through that once.
okay. So I think we have
For
found
the
the answer.
for the rotary part, it's inside the this no shaft sleeve.
No,
Understand?
rotating part will be rotating with the shaft. It will be on the shaft only. Yeah,
Yeah, on the shaft only, no, in between the shaft and the rotary part.
yeah,
So that O-ring will be there. So basically two O-rings for a mechanical seal.
yes.
Okay.
One will be inside and one will be outside of the mechanical seal, right?
Bro, you can just tell O-ring is present in mechanical seal and other is present in the shaft sleeve. That's all. No need to worry.
Okay, okay, all right. So what is the stuffing box?
You're asking me?
No, just in general. Can I please explain what is a stuffing box? Guys,
Well,
Akhil, can you
I
explain?
can try if no one is going
Yeah,
for it.
yeah, yeah, sure, sure.
Yeah, so basically, stuffing box is a sealing arrangement which is provided between the casing and the rotating shaft of the pump. Okay, so it has multiple slots in which we feed that gland packing material, which is either made up of graphite or Teflon. So what we are doing is we stuff that gland packing between these two. It is something like what we call flanges. Okay.
Yeah.
Yeah. So we put it in and we tight the bolts. So it provides the tight sealing between the casing and the shaft. Basically,
Yes, okay.
I had tagged somewhere, but I couldn't find it. I'll post the diagram on the group
Yeah, sure.
afterwards.
Yeah.
Yeah.
Can does anybody else wants to answer this question? Or I'll move on to the next question. What is the lanterning? What's the function of the lanterning? Guys, anybody want to answer? What's the function of the lanterning?
It cools
Yes.
the gland packing. It also lubricates and it also seals. So there are three main functions of a lantern ring in the stuffing box.
Okay. Yes,
Yes. Yes.
Gaurav?
Is a metal link which will be fitted between the gland packing and between the gland packing, and it is fitted over the shaft, which is give the three functions. One is cooling purpose, and one is the lubrication purpose, which is taking the outside or discharge side from the liquid, and it will put there, and it and this water will lubricate the gland packing and cools the gland packing also. And another is the cleaning purpose. It will be used inside the stuffing box. That is the main function.
To remove the impurities, it acts as a flush point, right?
Yeah.
Okay.
Yes. Yes.
So it flushes out the impurities that can get into the gland packing through the stuffing box. Correct? Am I right?
Where does these impurities come now?
I think through the stuffing box, the impurities can get into the gland packing. And
No, if
this
water
gland,
can pass to minute water particles can pass, but how impurities can pass? There can be
it,
leakage, right?
it
But there can't
won't
be
pass
any.
through. It can get into the stuffing box. Correct?
Okay, okay, okay,
So
okay.
this lanterning will act as a flush point. So the liquid will flow to the lanterning, and then it will protect it. It will remove the impurities, right? Okay.
Yeah, yeah. We move on.
Yeah. Kamlesh, you were going to explain it, right? With the image.
Yeah, I've shared an image of
Yeah.
a stuffing box. Okay. So in this image, you can see on the left side we have impeller. This at center we have shaft, and these blue things you are seeing here are packing rings, which are made up of either Teflon or graphite. By tightening these nuts, gland follower nuts, we squeeze these what is a gland like packing rings, and this like gets pushed against the shaft and the casing. So this prevents the leakage of water through the impeller or like from this part. Okay. So lantern ring here, you can see lantern ring basically is a slot provided through which water like water is flowing. The water is taken from the discharge side of the pump, and one connection is given to this stuffing box. So there are two main functions. First one is it provides a sort of lubrication, and second one is it provides cooling to the packing ring and slightly increases their life, and also the shaft's life. I doubt if it is flushes out the impurities, but if it does, the impurities are coming because of the friction between the shaft and the
I think the
packing
impurities are
rings.
getting in from towards like in the image you can see that gland follower, right?
Yeah, yeah.
I think the impurities can get through that side.
No, no, but do you have any like,
Yeah, actually, I have
reference?
read it somewhere. That's why I was saying. I can
Okay, okay.
share the reference.
Yeah, that will be better.
Yeah. I'll just share the reference. Yeah. Should we move on to the next question?
So, Kamlesh, this water
Yeah.
that comes, it flows over the gland packings only, or just it moves along the diameter of the shaft and then it moves like from the lantern ring, or does it pull the
No,
even the
see,
gland?
it can move. It can move around like in this area. It also
Okay,
pulls like yeah. It
that,
is
but
connected to. I think
that
I
won't
haven't
lead to
seen it
leakage.
physically.
That will lead to leakage,
See,
right?
I think
uh,
in centrifugal pump there is a little bit of leakage, right?
yeah,
Yeah, but they are
stuffing box doesn't provide
but you
100% of leak proof. It's not
Yeah.
but you're
100% leak proof.
purposely piloting and from the discharge side to this lantern ring, no? So I don't
See,
think
if
so.
you are
It
not
goes.
putting lantern ring, then the shaft will get overheated because of friction between these packing rings and
Yeah,
the
yeah,
shaft.
yeah.
Okay.
Okay.
So that's why you need something to cool it off.
But I don't know if it moves around the gland packing on
Yeah,
the
yeah,
right
yeah.
side.
I also have
Suppose it
little bit
moves,
doubt about it.
but it is fabric, no? It should go inside, I think. Sip inside the fabric.
Yeah. It does. It does.
Okay.
I think it seeps inside. Correct.
Yeah, I think
The
Yes,
it
yes.
liquid.
needs.
It should sip, and because of
Yeah,
the
it should
tightening
seep
effect, then
inside.
it gets drained. I think because of the tightening effect, no, it gets drained. I think itself
Yeah.
into
Correct.
the lantern. Yeah.
Because it is the gland packing is wrapped around the shaft, right?
Yes, yes.
Okay.
Yes.
Yes.
Yeah. Move on.
So, can you anybody explain what's the working of a centrifugal pump? First, what are the classification of pumps? Anybody would like to answer?
So we
Can I
have
tell?
two broad classification. So we
Yeah.
have rotodynamic pumps, then there are positive displacement pumps. So under rotodynamic, we have the centrifugal pumps and the axial flow pumps. While coming to the positive displacement pump, there are rotary types and the reciprocating type. Under rotary, we have the gear pump, vane pump, block pumps. While in the reciprocating, we have the piston pump. Under piston, we have the single acting and the double acting. So this is the classification.
And you can add diaphragm pump, correct?
Yeah, I forgot about diaphragm.
Yeah. So can we explain the working of a centrifugal pump?
Can I?
Yeah.
Initially, impeller is surrounded by fluid. When impeller start rotating, fluid also start rotating, and castor readily outward toward the casing because of centrifugal force act on the fluid. The centrifugal force act on the fluid, which fluid flows outward the castor readily outward to the case, and then vacuum pressure is created in eye of an impeller. In vacuum pressure is created in eye of an impeller, so there is a suction created, and then fluid flow circumferentially outward toward the discharge side. The casing area of the casing is gradually increasing to the discharge side. When the area increases, velocity decreases according to equation of continuity, and then velocity decreases, pressure energy increases according to Bernoulli's theorem. This is how discharge pressure is created in discharge side of the centrifugal pump.
Okay. Anybody else want to answer?
Can I try?
Yes.
So when we start the motor, the shaft connected to the motor rotates, which is further coupled with the impeller shaft, which rotates. This causes the impeller to rotate, which causes the fluid in the casing to move radially outward due to the centrifugal force of the impeller imparted onto the fluid. This causes a wide space at the eye of the impeller, which causes a negative pressure at the eye. That's how the fluid gets sucked. It moves along the volute casing. So design of the volute casing is such that the cross-sectional area goes on increasing. So the fluid that gained the kinetic energy gets converted into pressure energy as per Bernoulli's theorem. So this is how a discharge pressure is created at the discharge side of the centrifugal pump. This is how a pump works.
Okay. If they are asking the question like explain centrifugal pump, then everybody should explain everything, right? How is the suction pressure getting created? How is the discharge pressure getting created? Am I right? Or should you just make it short? Then you will cross question on how is the suction pressure getting created or how is the discharge pressure getting created?
Yes, preferably you should explain both suction discharge.
Okay. But then the cross question, like you won't be able to cross question, right?
Depends, no. If you want, you can.
Yeah. Correct. I think yes, you are right. We should explain it fully.
Maybe then you should answer. I mean, yeah, exactly. Can I try explaining it once?
Yes.
Yeah, okay. So there are two major components in an centrifugal pump. One is an impeller, then second is the casing. Okay. Uh, the suction part, pump sucks water from the eye of the impeller. Okay, as the impeller is connected to the motor and motor or like a driving component. So as the impeller rotates, it imparts its rotational energy to the fluid present inside the casing. Because of the centrifugal forces, the fluid moves away from the center towards the like circumference of the casing, and this creates some void at the eye of an impeller. So this is creating suction pressure in our pump. Okay. So the what like liquid, let's consider it as water, which is moving away from the center, flows through a volute casing of a pump. in which the area is gradually increasing. Okay, so as the area is increasing, velocity decreases and the pressure energy of the liquid is increasing as per the Bernoulli's principle and continuity equation. Okay, so then this water with high pressure energy is then discharged out at, like tangentially to the outlet port or discharge side of a pump.
Yes,
Yeah,
Yeah.
correct.
correct.
Is it tangentially correct? Saying at the discharge side it is thrown tangentially outwards. I
Uh,
have no idea
Yeah,
about it, but
I
it's
would say
like
it radial.
99% it's tangentially.
Yeah, it's
okay, okay.
radial. Yeah, I think what's the difference between radial and tangential?
Almost 99% centrifugal pump has tangential discharge.
The backward curves helps to radially output in impeller.
Sorry, what?
Uh,
It's not the backward, it's the centrifugal force of the impeller onto the fluid. Even if you have forward vane, it will still be throwing it radially outward. So it doesn't matter if it is radial or no, sorry, if it is forward, backward curved vane. So it's because of the
No answer.
centrifugal force.
It does matter.
Yeah, yeah,
It does matter. It does matter if the veins are forward or backward. Okay. So see,
okay,
okay.
if if the veins are forward curved, then what will
yeah.
happen? It will create more turbulence inside the casing, and this will lead to the cavitation. That's why the veins are backward curved.
Okay. But in a forward type of this impeller, where will the fluid be thrown? It will be thrown radially outwards, or So that's what I mean.
No, no. Fuel will see what will happen.
Yeah.
Okay, let's imagine a phenomena where you are rotating the pump in the opposite direction. Okay,
Okay.
so generally the fins of the impeller are like curved backward. Okay, so what's happening if the vanes are curved forward, like in the direction of the rotation, then it churns the water and creates turbulence. So it leads to the like drop in the local pressure and it creates like cavitation, which damages the impeller. So when the cavitation is happening, your discharge is reduced. So the efficiency of your pump will be reduced drastically. Do you getting me?
Yeah, I got you. But how will be the water be thrown? It will be thrown radially, from the
Sorry.
impeller eye to the discharge of the this impeller from this suction to the discharge. It will be thrown radially outward, Like if you consider the
No,
circle
no,
as
no.
the
Where?
impeller from the radius
Uh huh.
will be out from
I
the
didn't
eye to
actually get you.
okay.
He is saying that radially pushes the outward the fluid toward the casing.
I mean, it doesn't matter no if it is
Yeah, the
radial
fluid
like
will be.
oh yeah, radially outward only it will be moving. The fluid will be moved radially outward. Doesn't matter
Yeah,
if
it
it is
will
forward.
be pushed radially outward. But what's
Yeah,
happening in this case is you will see there is increased
yeah, that I
cavitation.
got. Yeah, turbulence and all I got,
Huh.
but it will be thrown radially outwards. Doesn't matter.
The but backward goes it helps for traps the more fluid and then smooth flow of the fluid, right?
It reduces the
Yeah.
vibration, right?
Cavitation.
It
Yeah, let's
reduces
move on.
cavitation.
Otherwise, we'll get trapped over here only. Let's move on.
Okay. So
Okay, is
what
this
is
coming in the recording? Sorry.
yeah, yeah. What were you saying? Kamlesh, you were saying something?
No, no, that's what I was saying. The veins should be like backward curve. Radially. Okay, someone is saying radially pushes outward.
Yeah, so Sean was also saying something. Yes, you're right. Radially out
Radially out
will
push more
pushes
water.
more water outwards. Okay, so if it will be radially, then more water will be pushed outwards. But how?
I didn't get it. What exactly happening here?
I
Let's
have a doubt
discuss
in
this
this
in
case.
the next session. Let's
Yeah, yeah,
research
yeah,
about it and then discuss.
yeah, yeah.
No, it's
Move on.
no, no. It will get.
Should we move on? Uh, what's Gyan's video on centrifugal pump here taught by showing a diagram. Okay.
Okay. Uh,
I've seen his video, but I think I forgot.
Let's
So,
move on, na, Surfraj?
let's move on. Okay. Okay.
Yeah.
Which pump is used on pump boiler feed water?
Same
Can I tell?
centrifugal.
Centrifugal pump.
it's
Centrifugal pump.
centrifugal pump.
Centrifugal pump.
Yeah, yeah, yes, correct. What is NPHs?
Net positive
It's
suction
positive
head.
suction head.
Can anybody explain?
It is the selection criteria. It tells whether the pump will work without cavitating. So the suction pressure at the suction side of the pump should be higher than the this vapor pressure of the fluid present. So this is the and also NPSH available should be higher than the required, which is given by the manufacturer.
Okay. And the formula for calculating NPH is available. Can you tell me the formula?
No idea about it. But this is asked in IMS. This is asked. No, I guess no.
Yeah, I think this is not asked because in the testimonials, NPH is, I think, not mentioned. But centrifugal
Yeah,
pump
but
and
can be asked. Can be asked.
yeah, it can be asked. NPH is a common question, I think. Yeah.
Yes.
Uh,
Absolute vapor.
yeah.
Absolute
Please
suction pressure.
share our formula.
Hello. Yeah. Absolute suction pressure plus minus friction losses and vapor pressure minus vapor pressure. That is.
Okay, absolute suction pressure plus or minus water head minus frictional losses minus the vapor pressure. Correct. Absolute vapor pressure. Am I right?
Yes.
Okay.
Now audible.
Yeah. Now you're audible. Can you really explain the differences between a centrifugal pump and a positive displacement pump? Who would like to answer it?
Can I
Yes.
first aside the centrifugal pump and positive displacement? First, basically in operational principle, it works. Centrifugal pump work on a principle of converting kinetic energy into potential energy by using impeller to create centrifugal force. And positive displacement works on a principle of trapping a amount of fluid in a chamber and reduce the pressure. After the flow rate, in centrifugal pump provide a stable flow. In positive displacement pump, they provide a relative constant flow. After that, pressure handling. Centrifugal pump has better suitable for high flow and low pressure methods. And positive displacement pump is used for high pressure and low flow. Coming to viscosity, centrifugal pump works well with low viscous fluid, and positive displacement pump works on both high viscous and low viscous, but efficiency may be differ. After the centrifugal pump required priming, positive displacement did not require priming, and the maintenance cost is compared to centrifugal pump. Positive displacement pump is high, required more area compared to centrifugal pump. That's it.
Yes. I think you had mentioned Maxima. Have you said about relief valve?
Uh, I did not hear.
Yeah, relief valve is not required in centrifugal pump and it is required in
Uh,
positive displacement pump. Right?
yeah,
Okay.
yeah. I need to
Uh,
add.
Anybody else wants to add a few more points? Akhil, can you?
Can I?
Yeah, sure.
Okay, so centrifugal pump is a type of a rotodynamic pump, while a positive displacement pump is a sorry. The working principle of a centrifugal pump works on the centrifugal force, wherein suction is created at the R and then the discharge is created because of the centrifugal force. While we have positive displacement pump, which traps a specific volume of fluid and then positively displacing it. Now, for the centrifugal pump, we require priming, while for a positive displacement pump doesn't require priming. A centrifugal pump, the rotary part is the impeller, while in the positive displacement pump, we have the rotary parts such as gears or screws, etc. In the centrifugal pump, we have a relief valve. No, sorry, it doesn't have a relief valve. While in a positive displacement pump, because of the high pressure created, we have a relief valve. These are the points of difference.
Yes. And I have also added few points like centrifugal pump requires less space and positive displacement pump requires more space. The initial cost of a centrifugal pump is less. The initial cost of a positive displacement pump is a higher. If you want to, you can add those points too. You answer is correct.
Space, how space can be a factor, like gear pump, if you consider positive displacement pump and a centrifugal pump, both will be same in space.
Centrifugal pump it's not smaller, right?
If you say a reciprocating and then a centrifugal pump, then space can be a major point of difference. But you can't say with a positive
Okay.
displacement pump because it can even have a gear pump, so it has a like enclosed structure, no, where gears are fitted. So it can be
Okay.
same as the centrifugal pump. So you can't say
So
space.
we can only say when it's like when we are comparing centrifugal pump and reciprocating pumps, correct?
Correct, because it will have its connecting rod and that other stuff, all of this
Yeah,
crankshaft and
yeah,
all. So it will require higher space. Got
got it.
it, right?
Yeah, yeah, got it. So, uh, anybody else want to explain, or should we move on to the next question? I think let's move on to the next question then. What a negative displacement pump? What are negative displacement pumps?
I not find anything about it. You all got?
I think
Kamlesh,
we
you
can
got
say
anything?
that centrifugal pump is a negative displacement pump, right?
How? How come?
Like
It's a
positive displacement.
rotodynamic pump, no? Rotodynamic pump, no? It works on the rotational energy of the impeller.
Yeah, but positive displacement pumps are those pumps that traps a fixed amount of fluid in its chamber, then pushes it
Yeah,
out and
and then
again.
yes, yes. So
So
how centrifugal will be negative then?
no, I don't have like I also have a doubt in this question. I was just asking. We can say it or we can't say it because I also didn't got
I
anything.
think the interviewer was testing the interview's knowledge, I think.
Yeah, this question I think only asked in interview
Yeah,
negative
yeah, yeah.
displacement pump because I have not seen it anywhere else. So what should be the correct answer?
I would say there were no that like there is no negative like this negative
Displacement pump
displacement pump. Yeah, yeah. He was testing his knowledge maybe. Whether he was
maybe, yeah.
saying something or
Because every
like that.
pump displaces some amount of fluid, right?
Yeah. If it displaces negatively, then what's the use of using a pump?
Yeah, yeah, yeah. Correct, correct. Can anybody explain the working of a gear pump?
Or can it be like vacuum or something? Negative displacement pump means like vacuum
I
creation or
find the
no?
answer, but I was not
Yeah,
getting any
can
proper
be
answer regarding negative. Like it's not. There's nothing like negative displacement.
yeah, yeah, that's what I was searching. Yeah, let's move on. Wait.
Yeah, I think this was just a one-time question, maybe. Who can explain the working of a gear pump? I just have one answer regarding negative displacement pump. I will share it in the group. That was not in any website and all. It was just in Quora. Okay. So can anybody explain the working of gear pump? Anyone?
Can I go?
Yeah.
When two gears getting out of the mesh, there is a vacuum pressure period. When area increases, pressure decreases, and there is a vacuum pressure created, and then fluid get traps into the gears and then it circumferentially move outward toward the casing, and then discharge is created, uh, getting into the mesh. When fluid is getting into the mesh, area decreases, pressure increases. This is how discharge pressure created, and then discharge of fluid is happening.
Yes, you are right. I think you can add the like before the suction pressure is getting created, you can add this part too. That there are two gears. One is the driver gear, one is the rotor gear. Both are meshed with each other. And when the motor converts electrical energy to mechanical energy, which rotates the shaft, rotating the driver gear, and the follower gear follows. And then we can say that when the gears are rotating, when the gears are coming out of the mesh, the area is increasing, due to which pressure is decreasing, and as negative pressure has been created, the fluid enters and then it flows towards the casing, right? And it gets trapped in between the gears and the casing. Am I right?
Yeah.
Yes,
Can I
yes.
try to answer it in the other way?
Yeah,
Similar, but I have the more structured answer, I think. So
yeah.
see, in external gear pump, we have casing and two gears meshing with each other inside the casing. Okay, one of them is driven by a the gears are coming into the mesh, and at the discharge side, gears are coming out of the mesh. So when the sorry, I just misplaced it.
At the
Right?
opposite way. Opposite
Yeah,
way. The
sorry.
suction.
At the suction side, gears are coming out of the mesh, and at the discharge side, gears are coming into the mesh. Okay. So when gears are coming out of the mesh, the volume between the gear teeth is like increasing, which creates some vacuum or negative pressure at the suction side. So the liquid is drawn inside pump casing. Then uh, this liquid, which is coming inside, gets trapped between the walls of the casing and the gear teeth, and then it is transferred to the discharge side of the pump. Okay. Over there, the teeth are getting into the mesh, which is reducing the volume and hence increasing the pressure. Hence, we get higher pressure at the discharge side.
Okay. Yeah, this is a much well structured answer. So, any cross questions regarding gear pump in the testimonial? I don't think there are any cross questions regarding gear pump. Yes, one.
Can
What if the gear pump is reversed? Then what will happen? Anybody?
Uh, I don't think there will be a major issue. The pump will start pumping in the reverse direction.
Yeah, I think that's it, right? If we if it's
But there
reversed,
can be some issues regarding the safety of the pump because the safety valve is at the outlet of the pump, right?
yeah.
No, Kamlesh, there will be difference.
But suction will not
See,
take place, right? Because the
see.
Okay,
yes,
okay. Answer.
So
Samson, yeah,
yeah, so motor is connected to the driver gear. So previously, if it has to work in the counterclockwise direction, so now if
Mhm.
the motor is reversed or the gear rotation is reversed, that means it rotates in the counterclockwise direction. Due to this, the suction side becomes the discharge side, and the discharge side becomes the suction side. You can see drawing by drawing the diagram on the piece of paper. You can see that suction side becomes the discharge side, and the discharge side becomes the suction side.
Yeah,
So
that's what I
the
said.
flow will be
It won't change
okay.
much. Only the pump will start pumping in the reverse direction. That is. suction will discharge
Will
into
the
the
suction
substrate.
take place when
That's what I
it will
mean.
be reversed? Will suction will take place or it will not take place?
Of
It
course, it will
will,
take place.
It will
It
take
will
place,
take
right?
place. Yes.
Okay.
yeah, but can anyone just tell me, like, there will be an issue with the safety valve. Correct me if I'm wrong. The safety valve is generally located at the out, outlet of the positive displacement pump. Am I right?
Yes.
Recommended.
I think have you wrote down a perfectly structured answer for this question? Do you have it?
Actually, I haven't wrote down the answers, but I had notes
Okay.
I prepared in the past.
So, what are the types of packings used?
So the gland packing and mechanical seal.
Yes, and differences between both.
Uh, which gland packing is a type of material? Which I need to say the differences.
Yeah, differences between a gland packing and a mechanical seal.
Yeah. The mainly difference is it is very cheap. Gland packing is very cheap compared to mechanical seal and easy to replace. Um, and used in low viscous fluid pump. That's it.
Yes, you are right.
Is it just me or uh,
Yeah.
Vijay? Can you be
Yeah.
a little loud?
Okay. It's very cheap compared to mechanical seal and also easy to change and used
Any
in
other points?
so that's it. Bro.
I think if this question is coming, first we should explain the structure, right? Like the gland packing is twisted fibers uh, that are wrapped around the shaft, which is fitted inside the stuffing box, and the mechanical seal is a two-piece component. One is the rotating part, and one is just stationary part. Rotating part is fixed at the uh, shaft, and the stationary part is fitted with the casing. I think we can explain in that way, right? Then the
And
points,
just a
But it
minute.
is only asked to the types of packings, right? So you have to only tell the packings. Then if it is asked, explain me the
like
gland packing,
differences
then you have to
between
be
both.
more specific. You said differences?
Yeah. Like first I was
Okay.
asking him types, then I got into differences. So if
Okay, okay,
he's
okay,
asking
okay.
differences, we can explain this way, right?
Yeah, you can explain now.
Yeah.
Okay.
Then
Sorry for interruption. Just
yeah.
can someone please repeat the types of packing? I didn't heard properly.
Vijay only had
Gland
So it is
packing
explained
and
gland
five types.
packing and mechanical seal.
mechanical
Are the
seal.
two types of packing.
These
I
are
don't think that's the right answer for this question.
Why
okay.
it's wrong?
No, it's not completely wrong. I
Okay.
think what the question means is, see, there are multiple types of gland packing. Uh, I mean, the material which is being
Ah,
used
yeah,
for the
okay.
gland packing. Okay, one
Okay.
like there is graphite, there is Kevlar. So general purposes, we use graphite gland packing, and for special purpose like some corrosive chemicals are there, then we are using like a Kevlar material gland packing. Okay, that's what the question means, I think, because of it is being followed by the question conditions based packing preferences.
Yes, condition based packing preferences. Yeah, that was the question. What I didn't understand this question. What was it? Condition based packing preferences.
Yeah, so condition based packing preference means, let's say you have two
Yeah.
pumps. Okay, one pump is pumping regular water, and the second pump which is pumping some corrosive chemical. Okay, so for regular pumping water, you can just use graphite packing. Okay, it's comparatively cheaper. But if you're using some corrosive liquid which is being pumped by your pump, then you must use something like a more like special purpose, like a Kevlar or a carbon fiber packing, which is which can withstand the corrosiveness of the nature of that liquid. So it will be little costlier as compared to a graphite packing, but it will get the job done.
Okay. And if the fluid is harmful,
Mhm.
then we can't use gland packing, right? Then we have to use a mechanical seal.
Yeah, for some specifically really, I mean, like there are some liquids where we are using mechanical seals instead of stuffing boxes.
So if this question will come condition based packing preference, then we can just give this answer: the types of gland packing that we use,
Yeah,
right?
that's what I think.
Okay, okay. Yeah, because this question I have never heard it before. I was
So
also
this is the answer for the types of packing, the condition-based packing preference.
Yeah. But still, if you have any sources, then please go and confirm this and update on the group. But this is what I think. This should be the answer for this question.
And even if
and
types of packings are, so that is the answer, right?
Yeah.
Okay.
we can also add the mechanical seal too, right? Because that is also a type of packing.
Maybe.
Yeah, I will try to get the answer to it.
Yeah. Just try to
Yeah, yeah,
get through it.
yeah, yeah. So in pumps, any more different questions? Let me see. Well, packing them. How do we start a centrifugal pump?
Discharge valve close.
Yes, sir.
Can anybody explain how to start a centrifugal pump?
Can I?
Yes, please.
Yeah. First of all, when we start centrifugal pump, we check it out first. You need to check all the discharge valve. After that, if any coolant is present in the if you need to prime the pump if necessary, depending upon the condition. And then we need after the starting the pump, after the pressure build up in the pump, we need to open the discharge valve depending upon the condition, by partially or fully.
Okay.
I think it,
Anybody else want to answer this question?
Can I?
Yeah. Please.
Initially, discharge valve is closed while starting the centrifugal pump. It can closes up to 15 minutes maximum. When the impeller is attaining the standard RPM and then torque, the discharge valve is slowly open. The flow will increases and then uh, current also increases. Am I correct?
Yes, you are right. The question is how to start centrifugal pump. Can we add this part too? That if the priming is required, then we can do the priming too.
Yeah, there is a two types of priming.
Yeah.
Manual priming and then reciprocating. Using reciprocating pump, we
Pump.
can prime the pump.
So if this question will come, what should be the answer? We can add priming too, correct? Understand?
Yes.
Okay.
I'll suggest don't go into explaining the priming in this question.
Yeah.
I have to answer the question. I'll go like this. When you're starting a centrifugal pump, make sure it is primed. Then make sure the discharge valve is closed. Then you start the motor. Uh, Wait until it reaches a certain RPM. Then open the discharge valve slowly. Okay. So maybe after this, you will face some cross questions like why you are closing this discharge valve.
Yeah.
And we would like to answer the question.
Yes. Yes. Please go on.
Okay. I'll try. So see,
You are asking
uh,
me, or I didn't
Yeah, anyone else?
Yeah. Okay. Anyway, anyone else wants to answer this question, or should he continue? Gaurav,
What is the question? Hello.
why do we
Why
keep
are
the
you
discharge
closing
valve?
the
Yeah,
close while
exactly.
starting the centrifugal pump?
Okay, we are closing the discharge valve start because of the current drawn in the initial position is the low. That's why we are centrifugal pump discharge valve will be closed. Due to which, when the discharge valve will be slow, at first when the pump will be started, the starting torque will be required to from the rotate the stationary position to a constant rpm. That is already required a higher amount of current. And otherwise, another when the discharge valve will be open, the discharge will be taking place. That is the another one resistance, head resistance will be acting on the impeller, and that is the more current will be drawn by the pump. That's why the windings can be damaged. That's why we are ensuring the at first discharge valve will be closed at first starting time. Then we gradually open the valve to starting the flow. That is it.
Yes, Gaurav, you answered it properly. Just you messed up one thing. While starting the induction motor, it will be drawing more current.
Yeah,
You
yeah,
said
yeah, yeah.
it will be drawing less current. So if you see the
Yes.
discharge
I will.
versus current graph of a pump, then you will
Yes,
see that in
I will told the starting torque will be required. That's why the only one point means the current will be also
yeah, you the after the answer
stored.
you said it
That is
properly. You
sorry.
just missed uh, said the only thing that like it
Yeah,
should
yeah, yeah.
you should be setting high current. You said low current. That's it. Otherwise, the answer was right.
Yeah.
Okay.
Okay. Kamlesh, you would like to answer it, or should we move forward?
Yeah, it was pretty much same. While you are starting a motor, it will be drawing high current because it will need high starting torque to start the motor. So if you are keeping the discharge valve open, if you see the discharge versus current graph, then you will see as the discharge increases, the current drawn by the motor will be increased. So if you are keeping the discharge valve open, then this discharge will also draws more current for the motor. This will lead to damaging of the windings. So that's why we keep the discharge valve shut and then start the motor, start the pump, and we open the discharge valve after it reaches a certain RPM.
Yes. So I think we have almost covered the IMS testimonial questions. Does anybody have any other questions regarding pumps? I think late we should continue in next session. Yeah, because it's almost it's going to be 2 hours. Does anybody have
I will
any
continue
question?
next time.
Yeah, yeah.
The workshop thing and the IC part.
Yes, yes, yes. We can. Thank you so much. So,
Uh,
anybody else has any other questions?
Before Sarfraz, I just want to ask one thing. Are you recording by parts?
By what? A bit late, so I recorded the whole session.
I did the same thing.
Yeah, me too. He messaged just now. He just messaged me just now that try to record it part by part. I recorded
Uh,
the whole session.
I think we have to cover it at like, editing part. Never
Yeah,
mind.
So
We'll see about it later.
while they ask for RAC components and VCRS components, are they not same? So RAC is based on the air conditioner. Is it
I
like
think
that?
we should
See,
just add
RAC
two more
means
points.
refrigeration and air conditioning.
Yeah.
Okay.
So if they are asking RAC, what I think they are asking is you are supposed to explain the VCRS system. That is uh, vapor compression refrigeration cycle.
Yeah. So
That's
it's
what
the
you are
same.
supposed to explain.
So it's the same thing.
Yeah, it will be the same thing, except in like there is a temperature and
Dryer.
what
Sorry,
else?
the humidifier.
The humidifier.
Humidifier.
Yeah.
Yeah, but I
Okay.
think that's a separate component. It doesn't comes under the RAC section.
Okay.
It I think it comes under HPAC or
So
something, but I'm
better
not
to
pretty sure.
explain the parts of the this, no? Air
Yeah,
conditioner.
VCRS. Go with the VCRS.
Okay. With the VCRS.
Yeah.
Okay. Thank you.
Okay. So I think we have wrapped up pumps. So I'm going to close the recording. Thank you so much, guys.